Okay, Jana. Okay. So it is zinc 2 positive, copper 2 positive, Fe2 positive, Fe3 plus positive. These most examples are sufficient. Now you will be telling me the electrons in d orbital. Okay, d orbital electrons for Se3 positive. How many will be there?
Ma'am, you are sharing your screen?
Yes, is it not shared?
No, ma'am, I can't see it.
Okay, I have shared. Can you see now?
Yes, ma'am, yes, ma'am.
Okay. So for Se3 positive, you tell me the d orbital electron for it. How many d orbital electrons will be there?
0?
Yes. Now for Ti4 positive.
Same, 0.
Next.
See, uh, 2.
How it is 2?
No, 1 second. Cu is
Un unpaired electrons you need to tell. Because here we need to find the value of n.
only 1.
For copper positive. How it is 1? What is the configuration for copper? The ground state 1?
3D10 4s1.
And if it
Okay,
is
only
copper plus 1, it is 3d10. So 0 unpaired electron. Okay. For
yeah.
Zn2 positive.
Again 0.
Copper 2 positive.
This one will be having 1, right?
Yes. Fe2 positive.
0? No, wait. 2 will be unpaired.
Fe is 3d6, 4s2. Fe2 positive will be 3d6. Now
Yeah.
if I fill these electrons, so it will be like this. How many unpaired electrons?
4.
Yes. 4 electrons for Fe. And now next.
5.
Yes, 5. Now how do we find the effective magnetic moment for these? Okay, we will be using this formula. Okay, we will be putting the number of d electrons here, so it will be under root of 0 into 0, so it will be 0 for this also.
Yeah.
0 Bohr magneton, 0 Bohr magneton. Here 0 0. Okay, here 1 is there, so 1 into 1 plus 2 under root. Okay, so under root 3, it is whatever is the
1.1.
value. Okay, 1.73 will be there, so it will be like that. So 4 also we are putting like this, so it will be 4 plus 2, 6, and under root 4, under root 24 will be there. For copper, it will be this under root 1.73, and under root 24, it is around 4 point something, 4.9. Okay, now this is similarly we are doing for all. Okay, this is under root 35, so some value will be there. Now I mean to say that the electrons which are having 0 Bohr magneton, the value of effective magnetic moment, it is 0. That means that they must be having the 0 unpaired electron, and if they are 0 unpaired electron, they are diamagnetic. This is diamagnetic. This has 1 unpaired electron, paramagnetic, and paramagnetic. Okay, so the type of question that you will be getting from this topic, that you will be given ions, such as you will be said to calculate the effective magnetic moment for all these 3 and arrange their values in a certain trend, like increasing order or decreasing order. Got it?
Yes.
Okay. So this is one type of question that you can get from here. Now the next topic.
Ma'am, one more term was there, right? Magnetic.
That is ferromagnetic. That depends upon the arrangement of electrons in the d orbital. Okay, that is like all the electrons, they are arranged in one direction. Some are arranged in opposite direction. Alternate arrangement is there in one direction and the second direction. So that is not related with this unpaired electrons. Only diamagnetic and paramagnetic are related with this. Okay, that will be the part of solid state only that you have studied there. Okay, now one type of question it is given in your NCRT. The based on this, it says that calculate the magnetic moment of a divalent ion sorry in aqueous solution if its atomic number is 25. Which will be the element?
Manganese.
Atomic number 25. Yes, manganese. Now they say that we need to calculate the magnetic moment, that is the effective magnetic moment of a divalent ion in aqueous solution. That means we need to calculate for Mn2 positive.
Yeah.
It is divalent. Yes.
Why we are taking it as 2 positive?
Because here it is divalent. Divalent ion means like we will be having charge of 2 positive. What is univalent? Valency will be 1, so the charge will be 1 positive. Trivalent, 1 plus will be like Na plus. Okay, divalent is like magnesium. What is trivalent? Trivalent is aluminium 3 positive. Okay, just like this. Okay, so here we have with atomic number 25, we have to take the divalent ion, so it is Mn2 positive. Okay, now how many unpaired electrons will be there in this?
3D, 5 4 is 2, 2 are gone, means 5 are there unpaired.
D5, right? And 5 unpaired electrons means that the magnetic moment will be 5 into 5 plus 2 under root, that is under root 35. That means the value is somewhat around 5.92 Bohr magneton. So understood which type of question can you get from this?
Yes, ma'am.
Okay. Yes. Now the second formula is spin only formula. Spin only formula. So it is mu into n plus 2 under root. So the unit is Bohr magneton only. Okay. Now in this also, you need to, okay, wait. The same formula is this. The effective magnetic moment that I told you the formula, that formula, it is known as spin only formula also, and effective magnetic moment. Okay. Yes, the type of question that you can get from here, it is like here in this question it was written as magnetic moment, so you got that this formula we have to use. The another type of question that you can get from this part is like you need to calculate spin only magnetic moment of M2 positive ion. Okay, Now this M2 positive ion is there. Here Z is equal to 27. Now, how to solve this type of question? They are saying that the value of Z, that is the atomic number, it is 27. Okay, which will be the element here? 27.
Ma'am, after iron, what is it?
Scandium, titanium, vanadium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. You have to learn this, okay? You have to learn all the 3D, 4D, 5D series. Now here we have cobalt. Okay, cobalt is 27. What is the configuration here? 3D7, 4s2. Now they are saying that we have to take M2 positive ion. So it is cobalt is cobalt 2 positive, that is 3D7. Now if you see that how many d electrons are there in D7, it is 1, 2, 3, 4, 5, 6 and 7. 3 unpaired electrons, and we need to calculate the spin only magnetic moment, or simply they can write effective magnetic moment also, or they can write the magnetic moment also. Okay, so mu is equal to 3 into 3 plus 2, that is 5 under root, it is under root 15. Okay, whatever the value is of 15, so the value will be the value of spin only magnetic moment. Okay, okay.
Yes, ma'am.
Okay. Now the next topic is formation of complex compounds. Okay. This formation of complex compound, actually what we have started, we have started wrongly. First we need to do the coordination compounds, then we need to do the D block. But let me, because every topic here it is corresponding to the coordination compound, so I'm searching a type of topic which can be done here individually. Otherwise I would have to start coordination compound side by side with this D block. Give me 2 minutes. Okay, the next topic we will be doing is formation of colored ions. Okay. Now most of the transition elements, TM I'm writing, they correspond, most of the transition metal compounds are colored both in solid state and in solution. Okay, this is the first point. The second point is cations containing incompletely filled d orbitals are colored. Example is Fe2 positive, Fe3 positive, Cobalt 2 positive, nickel, copper, and titanium 3 positive. Okay. And cations containing completely filled or all empty d orbitals. Okay, they are colorless. That means that the cations that have partially filled d orbitals, they are colored, and the cations that have completely filled d orbitals, they are colorless. Okay.
Yes, ma'am.
Now, if you see, the third point is Se3 positive and titanium 4 positive. What will be the configuration for this? It will acquire the noble gas configuration, this also and this also. That means that they have all empty d orbital. Okay, all empty d orbitals.
So they'll be colorless.
Yes. And all completely filled are copper positive, zinc 2 positive, and Ag positive. They have completely filled d orbital, so they are colorless. Okay, now what is the mechanism, what is happening which is making these compounds to be colorless or colored? Okay, now the explanation for this is the color of the transition metal cations. It is explained using crystal field splitting. Okay, crystal field splitting. Okay, it is like when a ligand, it approaches a transition metal cation. Okay, when a ligand, for example, I'm taking a coordination compound, like I have the central metal to be titanium and this 6H2O, they are ligands. So when a ligand, it is approaching the central metal cation, okay, this is the cation, when it is approaching, the energies of the 5d orbitals, okay, they do not remain equal. Initially we have these 5d orbitals of same energy, okay, they are degenerate. This is dxy, dyz, dzx, dx square minus y square, and this is dz square. So initially they are at same level. Okay, when a ligand, it approaches the metal cation, the d orbital, they split into two sets. They split into two sets. The lower cell has 3 d orbitals and the upper one has 2 d orbitals. The upper one is Eg orbital and lower one it is T2g orbital. Okay.
Yes, ma'am.
Okay. Now the second thing is when light falls over a transition element, here we have a transition element, this is a transition element, and when light falls on this transition element, then what happens? The electrons of lower energy, okay, the electrons that will be in this lower level, the electrons of lower energy, they absorb a particular wavelength of this light that is falling on them, And when they absorb this wavelength of this light, they acquire energy so that they can jump from this lower level to the higher Eg level. Okay.
Yeah.
Now the color of transition element, it is corresponding to that DD transition. Then these electrons from the lower level, they are excited to the higher level. When they are transited to the upper D level. So the color of the transition metal compound, it is due to that DD transition. Understood? Because
Yes.
of that excitation of electron. Okay. Now, which color we will be observing? The observed color. The observed color is complementary color. Complementary color of absorbed wavelength. Okay. The observed color, it is complementary color of the absorbed wavelength. So this is how the transition metal compounds, they exhibit different colors. Okay. Corresponding to the wavelength of the light that is falling on them. Clear?
Yes.
Okay. Okay, Joanna. So tomorrow we will be doing the next part.
Ma'am, before is
Yes.
it before Monday? Is it possible? Also,
Yes.
before Monday, is it possible to finish our minds also?
Before Monday?
Yeah, because I have exam on Monday.
Which exam? Pre-boards?
Yeah.
No, it's not. Which topics are cancelled in this? Wait, let me stop the recording first.